Hi everyone, welcome back to my channel. Now, let me ask you something. Have you ever wondered how cartoons move so smoothly? Until the early 2000s, cartoons were created by rapidly displaying sequences of hand-drawn images. Animators used traditional animation technique to create cartoon animations dating as far back as the invention of the penakistoscope in 1833. So before digital animation, animators had to draw thousands of images just to create motion. That is around 30,000 drawings for a 20-minute cartoon. But here's the interesting part. That movement is actually math. Yes, geometry. And today, we're going to explore how movement in geometry works through something called rigid motions in a plane. So let's start simple. Figures in the plane can slide, flip, turn, enlarge, or reduce to create new figures. The original figure is called the pre-image, and the new figure is called the image. So basically, pre-image to image. Think of it like before and after. In geometry, when a figure changes position, orientation, or size, we call that a transformation. Now, not all transformations are the same. Some transformations keep the shape and size the same, but some of them change them. That's why we classify them into rigid motion and non-rigid motion. A rigid motion is when an object is moved from one location to another and the size and shape of the object have not changed. So the resultant figure is going to be congruent to the original figure. That means for A and B, the segment AB should be equal to segment A prime B prime, where A prime and B prime are the images of A and B respectively. And when we say congruent, two figures are congruent if same ang side lengths, same ang angle measures. So if you can move one figure to match the other exactly, that's rigid motion. Hence, we say that triangle ABC is congruent to triangle A prime, B prime, C prime. In today's video, we will discuss 5 transformations, 4 of which are rigid motion, namely translation, reflection, rotation, and glide reflection. And we have one non-rigid motion, which is dilation. So let's start. The first of the 4 types of rigid motion, translation. So translation is a slide. It is when a figure can be slid in any direction. Yes, left, right, up, or down. Basically, no turning, no flipping. The next one is a rotation. A rotation is if a figure can be turned around a point. So this is basically a turn, like rotating a fan or clock hands. The next one is reflection. So reflection is if a figure can be flipped over a line. So yung line natin, yung tinatawag nating mirror line. It's like seeing yourself in a mirror. And if you have a combination of reflection and translation, then that's the time that you get glide reflection. So this is basically a slide and a flip. And the only non-rigid motion is dilation. Dilation is when a figure can be enlarged or reduced. So it's still a transformation but not a rigid motion. Why? Because it changes the size. So the resulting figure will not be congruent but will still be similar. So let's try example 1, naming transformations. Using the graph of the transformation at the right, A, name and describe the transformation. B, name the coordinates of the vertices of the image. C, is triangle ABC congruent to its image? You may pause this video if you need more time to think of your answer. Okay, so the answer for letter A is the transformation is a reflection in the y-axis. So you can imagine that the image was obtained by flipping ABC over the y-axis. For letter B, the coordinates of the vertices of the image, triangle A prime, B prime, C prime are A prime is 4, 1, B prime is 3, 5, and C prime is 1, 1. Lastly, to answer the question, is triangle ABC congruent to its image? The answer is yes. Triangle ABC is congruent to its image triangle A prime, B prime, C prime. One way to show this would be to use the distance formula to find the lengths of the sides of both triangles. Then you can prove it using the SSS congruence postulate. Now here's a term you might hear, isometry. This is just a fancy word for a transformation that preserves distance in angles. So basically, all rigid motions are isometries. So example number 2, identifying isometries. Which of the following transformations appear to be isometries? You have letter A, letter B, and letter C. If you need more time to think of your answer, you may pause this video. So to answer the question, which of the following transformations appear to be isometries, let's go over all of our givens. So for letter A, this transformation appears to be an isometry. So the blue parallelogram is reflected in a line to produce a congruent red parallelogram. For letter B, this transformation is not an isometry. The image is not congruent to the pre-image. As you can see, our pre-image is a bit larger than our image. And lastly, for letter C, this transformation appears to be an isometry. The blue parallelogram is rotated about a point to produce a congruent red parallelogram. So, you can describe the transformation in the diagram by saying triangle ABC is mapped onto triangle A prime, B prime, C prime. Again, when we say mapped, we mean to say that a figure was moved. Hence, a transformation happened. And another way of describing transformations is using the arrow notation. Just take note that primes may be used to label the image. And the order in which the vertices are listed specifies the correspondence. So the description implies that A is mapped onto A prime, B is mapped onto B prime, and C is mapped onto C prime. So let's try an example in preserving length and angle measure. Here we have in the diagram triangle PQR, which is mapped onto triangle XYZ. The mapping is a rotation. So given that the mapping of triangle PQR to triangle XYZ is an isometry, because rotation is an isometry, find the length of segment XY and the measure of angle Z. You may pause this video if you need more time to think of your answer. Okay, so the statement triangle PQR is mapped onto triangle XYZ implies that P is mapped onto X, Q to Y, and R to Z. Because the transformation, which is rotation, is an isometry, the two triangles are therefore congruent. So, segment PQ is going to be congruent to XY. Hence, based on the diagram, if PQ is 3 units, then the segment XY is also 3 units. Moreover, since Z is mapped to R, the angle measure of Z is congruent to angle R. Hence, angle Z should be 35 degrees. Got it? So to summarize, a transformation is basically a movement of a figure in a plane. And we have two types of transformation. We have the rigid motion and the non-rigid motion. When we say rigid motion, it's a transformation that preserves the size and the shape. We have 4 types of rigid motion, namely translation, rotation, reflection, and glide reflection. And there's only one non-rigid motion, which is dilation. If you want to try some exercises, you may go over these examples. Pause the video if you need more time. If this helped you understand rigid motions better, don't forget to like, share, and subscribe. And if you have questions, comment down below. See you in the next lesson.